First, I just want to describe a little bit more the specific process they have for this. This E. coli expressed protein is isolated in inclusion bodies, which also makes it difficult to make a process-specific ELISA assay. So you start out with the step 1 is a renaturation step. Then they have an ion exchange column as step 2. Then they do an enzymatic treatment in step 3. It's a aminopeptidase treatment, followed by a reverse phase column purification, and then again an ion exchange chromatography step, and finally they have the final drug substance produced. So 6 steps procedure, and the good thing about mass spec is that it doesn't. It can actually take samples from all of these different steps, even though they are very, very different. The samples you get out. So you can imagine that it's quite dirty after step 1, and in the final drug substance, it's quite purified. So we use exactly the same method for all these 6 steps. So no changes there, and no optimization needed to be implemented. So, and this is how the data look when you have analyzed the six samples. And you can see here that for the first one, after step 1, we had more than 500 HCPs detected, quantified, and we have a total of almost 20% HCP in the sample. And as we go along, of course, we get fewer and fewer HCPs, and ending up after step 6 with 8 HCPs left and approximately 400 ppm. So this is comparable to what you would get from an ELISA. So a total number of ppm of HCPs in your sample. But on top of that, you get this detailed information about which individual HCPs do you have in the sample. So you get the name, the accession number, the PI, the molecular weight of any given HCP we find in your sample. And you can also really easy monitor in which step is it actually that I remove or purify the drug substance for this specific HCP. And again, now you have these data about the individual HCPs, you can start evaluating and making decisions if any of those you see on your list in your final drug substance, if you think that they might be of concern. So you can make this risk assessment evaluation early on and make sure that you don't have any that you don't want to have or you might foresee that can cause problems later on. So for example, if you have HCPs that might be immunogenic, or if you have HCPs that might have enzymatic activity, you would probably like to remove those to increase the stability of your drug substance and to remove the risk that you fail later on in phase 2 or 3 because you have immunogenic reaction from test persons.